Section 5.1 continued. This time we're going to look at factor by grouping. Last time we looked at the idea of greatest common factor. Now we're going to look at a type of factoring that is used for particular problems. And by the time we get done with these 4 sections, we're going to have several problem types that we're going to need to recognize what attack we're going to use to get them factored. So today we're going to look at problems of the type for which factor by grouping will work. Factoring is unmultiplying. As far as greatest common factor goes, that meant undistributing. Let's consider a multiplication problem first. Here we have 2 binomials. If I'm going to multiply 2 binomials, I can use FOIL. The first, A times C. The outside plus A times D. Product of the inside plus B times C. And product of the last plus BD. None of those are like terms, and so there's my answer. Now, remember what allows us to use FOIL, as well as any of the term-by-term multiplications. FOIL works because of the distributive property. Remember when I turned the first binomial blue, and I distributed to each of the 2 terms in the second binomial. Then in the next step, we distributed back into the first blue one and back into the second blue one until we had all 4 terms, and then we recognized those came from the first, the outside, the inside, and the last. Well, if I'm going to undo that process, if I'm going to now factor this polynomial of 4 terms, I need to return to that idea of where FOIL came from in the first place. Factor by grouping works like this. We know that addition is associative. So I can group this however I want. I can group the first pair, and I can group the second pair. Let's look at just the first pair and factor out a greatest common factor. The greatest common factor between these 2 terms is A. If I factor out an A, what's it going to leave behind? It's going to leave C plus D. And plus, factor out the greatest common factor from the last 2 terms. Well, I can factor out a B. What does that leave behind? C plus D. Now, how many terms do I have? You should recognize this problem type as the ones we finished up doing in the last lecture when we looked at the first part of 5.1. We have 2 terms separated by this black plus in the middle, and these 2 terms have a common binomial factor of C plus D. So I can factor out C plus D, and what does that leave out of these 2 terms? Take the C plus D out of this first term, leaves the A. Take the C plus D out of the second term, it leaves plus that B. And this is factored. Look, we've returned from the answer to a multiplication problem back to the original multiplication. Now, granted, my factors are not in the same order, but that's okay. Multiplication is commutative. So it doesn't matter what order they're in. What matters is that I can undo this multiplication by what? Undistributing, undistributing, and undistributing again. How does FOIL work? We distribute, we distribute, we distribute again. And then we discover the shortcut FOIL. So if I'm going to undo that process, When I have 4 terms, I'll use factor by grouping to undistribute, undistribute, and undistribute again. Or factor out that greatest common factor. Factor out the greatest common factor, and factor out the greatest common factor again. So that's the idea. We'll know to try factor by grouping when we have a problem that starts off with 4 terms. So let's grab some homework problems. And I'm going to start with number 80. Her instructions say factor by grouping. Now she's still holding your hand here a little bit. My instructions, by the time we're done with these 4 sections, will simply say factor. And you will know to use factor by grouping because you see 4 terms. I see 4 terms, I'm going to think factor by grouping. Now, of course, she has a blue box on page 335. Page 335, just below the center of the page. And she says, step 1, group the terms. Step 2, factor within the group. Step 3, if possible, factor the entire polynomial by factoring out that common binomial factor. Step 4, we'll look at here toward the end of the lecture. Step 4, it says, if necessary, rearrange the terms. So, step 1, group. Group the first pair, group the last pair. And then she says, factor within the groups. Out of the first pair, what can be factored out? What is the greatest common factor between these 2 terms? They each contain an m. Factor out the m. If I factor an m out of these 2 terms, what's left? Pull an m out of m squared, it leaves 1m. Plus, pull an m out of 2m, it leaves the 2. And now this plus sign. Now within this group, factor out the greatest common factor. Greatest common factor here is clearly n. Factor out the n, and what does that leave? M plus 2. You can always double check this step. Distribute back in, distribute back in. Does it return the original 4 terms? Now I have 2 terms separated by this plus sign in the middle. These 2 terms have a common binomial factor of m plus 2. If I factor out that m plus 2, what's left behind? Out of the first term, if I pull out the m plus 2, it leaves the m. Out of the second term, I pull out the m plus 2, it leaves plus n. And this is factored. You can always check these. You can always check these by multiplying them back out. If we FOIL this back out, the first, m squared. The outside, plus mn. The inside, plus 2m. And product of the last, plus 2n. Are those the 4 original terms? They're in a different order, but yes, those are the 4 original terms. And we know that the order doesn't matter when you're adding. As long as signs stay with their terms, we're in business. Let's do another one. Let's grab number 90. Again, she says factor by grouping. But by the end of all this, my only instruction will say factor. What is it that allows me to group these in pairs? It's the associative property of addition. The associative property of addition says it doesn't matter how I group an addition problem, it will give me the same result. In other words, I can put those parentheses in place without changing the value of the original problem, so long as everything is what? Addition. Well, I have no problem grouping the first pair, but I can't group the second pair with respect to subtraction. That would be an issue. If I put parentheses around 2y plus xy right now, I would be changing the value of the original problem. I mean, think about it. Originally, I have a minus 2y and a plus xy. So if I group like this, what do I have now? Distribute that negative. I have a minus 2y, but what? A minus xy. So I've changed the value of the problem. Well, then how can I group that last pair and still be talking about the same original value? Well, force this to be addition. Make this plus a negative 2y and group with respect to addition. That sign belongs to that term. Don't chop it off. You don't want to chop off a negative. Keep that sign with its term. Now that I've grouped with respect to addition, let's factor the greatest common factor out of the first pair. Between these two terms, the greatest common factor is 3. Factor a 3 out of 6, it leaves a 2. Minus, pull a 3 out of 3x, it leaves the x. Now out of the second pair, the greatest common factor is y. But if I factor out a y, what will it leave behind? A minus 2 plus x. At this point, I need these two binomial factors to match so that I can factor them out, and they don't. But they're awfully close. They're just opposites of each other. Instead of factoring out a y, what should I have factored out? What if I ask the question this way? Instead of factoring out a positive y, what should I have factored out? If I factor out a negative y, if I pull negative y out of negative 2y, what's left behind? A positive 2. If I factor a negative y out of positive xy, what's left behind? A negative x. Not sure? Distribute. And won't that return the original negative 2y and what? Positive xy? And look what else has happened. My binomial factors match. So now I can keep going. I can factor out this common binomial factor of 2 minus x, which will leave what? From this first term, it leaves the 3. From this second term, it leaves the minus y. And once again, we could FOIL this back out to check it. It should return these original 4 terms. Maybe not in the same order, but the same 4 terms. Quite often the question comes up, is it okay if I write this as the 3 minus y up front and then the 2 minus x? Is that okay? Yeah, that's fine. Because multiplication is commutative. So it doesn't matter what order those factors are in. I'm in the habit of factoring a greatest common factor out to the front or to the left, and so that's where mine ends up. If you've done this type of problem before and you're used to pulling out to the right, help yourself. There's no problem. These two answers are, for all intents and purposes, identical. All right, I've got one that I want you to try. Number 82. We'll back up now and grab number 82. She says factor by grouping. Later on, when all I'm saying is factor, you will know this is factor by grouping because it has 4 terms. When I see 4 terms, I'm going to try factor by grouping. Go ahead and pause the video here. Give that a try and come back and compare answers with me. I see 4 terms, so whether she has said factor by grouping or I have said factor, seeing 4 terms, we should know this is factor by grouping. Group the first pair. Group the last pair, which we're okay to do because that's a plus in the middle. I can group with respect to addition. I don't have to make my 2 marks to keep a negative with that third term this time. Out of the first pair, the greatest common factor is y. Pull out that y. It leaves y minus 6. And plus, out of the second pair, greatest common factor is w. If I pull a w out of each of those terms, it will leave me y and minus 6. And my binomial factors match. So I now have two terms, separated by this plus in the middle. I have two terms that have a common binomial factor that I can now factor out. Factor out the y minus 6, and what's left behind? A y plus w. This can be checked by FOIL, as always. How'd you do? Let's have a go at number 92. This one I also want you working ahead of me. Number 92. We have 4 terms in the original polynomial, so we will expect to attack this using factor by grouping. So you go ahead and give that a try, and remember, right there in the middle, be very careful. Go ahead and give that a try, and then come back. And if you want to check with my first step, just to see if you've got that first step right before you finish, roll the video and check your first step. Anyway, you go ahead and get started, and then come back and we'll compare. To get this one started, I want to group. Group the first pair, no problem. Group the second pair, we have a problem. You cannot group with respect to subtraction. You can only group with respect to addition. So we need to make 2 marks. Keep that negative with the 5ts. Now we can group those last 2 terms. Well, I made a mess. Let me try that again. Keep that negative with its term, and then you can group the last 2 terms. Out of the first pair, what is the greatest common factor? First, as to the numbers, 10 and 2, they both contain a factor of 2. And as to my variables, they both contain some t's. The smallest power on t is 2, so t squared. Do they both contain some s's? No. So the greatest common factor is 2t squared. Factoring out 2t squared, and if you didn't get this part right, pause again and fix this. Factoring out this 2t squared out of 10t cubed, it will leave behind, pull a 2 out of 10, it leaves 5. Pull a couple of t's out of 3 t's, it leaves a single t. And minus, if I pull 2t squared out of minus 2t squared s squared, it'll leave me minus. I pulled out the 2. I pulled out the t squared. The only thing that's left is the s squared. Now, out of the second pair, can you look a little bit ahead? The greatest common factor between these 2 terms is s. That's all they have in common, is a single s. But is that what I want to factor out? And I can try it, and if it's not, I'll erase it. But a lot of times when I make these 2 marks, I have to consider, do I want to pull out the positive or the negative? And if I pull out just an s, it's going to leave minus 5t plus s squared. And now look at my 2 binomial factors. So if I can look a little bit ahead, was it an s I needed to pull out? Not this time. Not the positive s, but factor out a negative s. If I pull a negative out of a negative, it leaves a positive. I pull s out of 5ts, it leaves 5t. Pull a negative out of a positive, it leaves a negative, right? Because if I were to distribute this back in, that's how I'm going to double check myself. That should be negative right there. And if I pull a single s out of s cubed, it leaves s squared. Double check, distribute back in. Does it return the original 2 terms above it? That works. And my binomial factors match up. Now, if you want to finish this off, go ahead and pause. and then we'll compare. To finish this up, I will factor out this common binomial factor of 5t minus s squared. If I pull this binomial out of this first term, the terms here are separated by this minus, right? The minus actually belongs to the second big term. If I pull this binomial out of the first term, it will leave me a 2t squared. And if I pull this binomial out of the second term, it will leave that minus s. As always, this can be checked by FOIL. How'd you do? All right, let's take a look at number 96. In number 96, well, let's just wait and see what happens. Number 96. I see 4 terms. So let me try factor by grouping. I'm going to stick with one color this time. Let me try factor by grouping. Group the first 2. Make 2 marks to keep that negative with its term. Group the second 2. Keep that negative with that 3xy. Out of the first pair, well, greatest common factor is 1. There's nothing wrong with that. It just means that in a minute we might have to recognize that there's a 1 sitting there. Out of the second pair, greatest common factor is 3. So if I factor out a 3, it's going to leave minus xy and plus 7. My 2 binomials don't match. And pulling out a negative 3 is not going to help, is it? If I had pulled out a negative 3, all it would do is change these 2 signs. That still doesn't match. So what's the deal? When you have 4 terms, there are 24 different ways to arrange this one polynomial. 24 different ways that you can arrange those 4 terms. Of those 24 different ways, only 8 of them will factor by grouping. That is, if the original problem will factor by grouping, only 8 of them will give you something that is factorable by grouping. The other 16 will land you with something like this. So this is one of those problems where I may need to rearrange my terms. Let me just go ahead and rewrite this problem. The original problem. Now, how do you want to rearrange this? Because there are 8 ways that might work. There's 16 ways that definitely won't. Well, how about we get our x's together? Let's consider that a pair. What if we consider our x's here a pair? Let me bring them up front. And then that's going to give me a plus 7y and plus that 21. That's one possible arrangement. Now, to be honest with you, this is not the slickest arrangement. You get a feel for that the more of these that you do. But there are a couple other things I want to talk about as we look at this. First of all, notice these are both negative. These are both positive. Don't you think it would be a good idea after grouping, and notice we're not cutting off anybody's negative, don't you think it would be a good idea to factor a negative out of these first 2 along with the greatest common factor? Because we know that when we're done factoring here, both of my terms will end up positive. So in addition to factoring out, what's greatest common factor here? 3x. Let's factor out not only the 3x, but the negative along with it. Factor out the negative 3x. If I pull a negative 3x out of negative 9x, that will leave me at 3. If I pull negative 3x out of negative 3xy, what's left behind? A plus y. Not sure? Distribute back in real fast. Make sure you get those original two terms back. Okay, now out of the second pair, greatest common factor is 7. And if I factor a 7 out of 7y, it leaves y. Pull a 7 out of 21, it leaves a factor of 3. Do my two binomial terms match? Yes, they do. Because I know that addition is commutative. So 3 plus y and y plus 3 are the same thing. Call it either one that you want. I'm going to call it y plus 3. I'm going to factor out this y plus 3, which will leave behind a minus 3x and plus 7. Now, depending on how you rearranged those four terms, you might get something that looks a little different. Here are some other versions of this same answer. Okay? 3 plus y times 7 minus 3x. Those are the same. 7 minus 3x times y plus 3. That's the same. Minus 3x plus 7 times 3 plus y. That's the same. And I could keep going. There are several different ways to arrange these two factors. Can you determine that all four of them that I have on the board, in addition to whatever she might have written in the back of the book, is the same? Can you tell that your answer, once you get it, matches whatever she has in the back? Look at it closely and say, do I have an equivalent form of the answer? There are times when you need to rearrange. Now, let me give you a little hint on rearranging. I wanted to do it this way to address a couple of issues. But really, if I go back and look at this problem, and I've already discovered that it won't factor by grouping the way it's written, I don't like having negatives in the middle. I like my negatives to be on the second and the fourth term. It just seems to make things cleaner. And so, what if I do this? What if I put 7y, and let's get this other term with a y up close to it, minus 3xy. I don't want a minus right in the middle. There's nothing wrong with it. I know I can make 2 marks, but it's just a little cleaner if I put plus 21 and then what? Minus 9x. There's another arrangement of these four terms. Will this arrangement factor by grouping? Let's find out. I don't have to worry about making 2 marks because I'm grouping with respect to addition. Out of the first pair, I can factor out a y, which will leave 7 minus 3x. Out of the second pair, greatest common factor is 3, which leaves 7 minus 3x. Look how clean that is. Pull out the 7 minus 3x, and it leaves y plus 3, which is an equivalent answer. I don't know if it's one that I had already written down, but that is an equivalent answer to what we had before, and you can always FOIL this to check and see if it returns those 4 original terms, not necessarily in the same order, but those same 4 terms with the correct signs on each term. So this is factor by grouping. I know to attempt factor by grouping when I see 4 terms in my factoring problem. I'll let you finish up the homework on this section. Not too many more problems to do, but lots of practice. Do every one of them, because in the next section we're going to learn a different type of factoring for a different type of polynomial, and so on and so on.